Hello, welcome to the Machine Learning at Home. Today I will tell you about very interesting, I would say curious idea, which however is quite helpful for one specific reason of machine learning. This method called anti-clustering. So clustering, as you know, is a way to find similarities, to maximize similarities within groups, and of course to minimize similarities between groups. Anti-clustering is a method which is completely reverse. It will maximize similarity between groups and minimize similarity within groups. So it will create sets of most unsimilar exemplars. This is very useful for specific reason to make a sample for the machine learning. So typically when we take a sample, we use some core R function or simply select every fifth row of the data set, or maybe we'll count about how big are groups and then we'll sample some particular percent of each group. This is not quite good because groups might have some internal similarities and dissimilarities, and these typical methods of sampling do not count for them. So let me show how anti-clustering is working. We need to install the package. So it's already installed on my computer, and I will simply call it library anti-clustering. I'm sorry. And before the T. Okay, sounds like I made it. So it is loaded, and if you don't have it loaded, you need to install it with install.packages command. Now we're ready to make some anti-clustering procedures. So for example, if we want 10 different classes, each class is as dissimilar as possible, so kind of a very random set, very interesting. So let me show how to make it. Function is anti-clustering, and we'll make it on the same example of iris dataset like I did almost all my machine learning examples, without column number 5, which is a species name column, and I will specify number of clusters, anti-clusters actually, and will specify which categories to use for anti-clustering. That's important because the method must know what are natural classification in that regard. So categories equal to iris column number 5 or species, and everything will go into the one object. For example, iris AC. Yes, mistake was that I forgot minus here. Okay, now I will make my clustering, anti-clustering, somehow visible. How to make it? Well, first of all, we can make some kind of table. And look how these anti-clusters correspond with species. As you see, almost each species has an equal number of the clusters. So for anti-cluster number 2, for example, 5 components belong to Setosa, 5 for versicolor, and 5 for Virginica. So very nice equal representation of each species. Now we can make less number of clusters and see how misclassification table is working. So let me make 3 clusters, like number of species. But again, this is anti-species. Each cluster will contain representatives of each species then. And then for misclassification table, I will need my package. And then I will make misclassification table from iris AC, my new object, and iris species. So if clusters, anti-clusters are random, then misclassification error should be about 2/3, exactly what we see here, 66.7%. This is exactly 2/3. So perfect method to find absolutely random set. So each of these 3 anti-clusters could be used, for example, as a training group for any machine learning. And of course, this is have more prospective applications. I encourage you to think how this anti-clustering may be used for other purposes as well. So this is a very simple but extremely curious method of anti-clustering, which makes us unsimilar groups as possible, internally unsimilar groups which have as less in common as possible. Thank you very much.